Here's something that will mess with your head tonight. Every map you've ever seen, every photo from space, every lesson your teacher gave you, what if it was all built on an assumption? Not a lie, not a conspiracy, just an assumption we never personally verified. What does the horizon actually prove? What if the edge was real and someone or something was making sure you never reached it? Tonight, we're not here to argue with science. We're here to do something science actually loves. Ask the uncomfortable question. What if the Earth was flat? Not as a belief, as a thought experiment. Because when you actually sit with the physics of a flat world, things get very strange, very fast. Let's start with gravity because this is where the flat Earth idea quietly falls apart, and it's fascinating to watch it happen. On a globe, gravity pulls everything toward the center of the sphere. That's why you feel weight wherever you stand. But on a flat disk, gravity would have to pull toward the center of the disk, which means the closer you live to the middle, the more normal things feel. But the closer you walk toward the edge, it would stop feeling flat. It would feel like you're climbing a hill that never ends, your legs getting heavier, the ground tilting under you, almost invisibly. Trees near the edge wouldn't grow straight up. They'd lean inward toward the center, like they were trying to escape something. And the oceans? All that water would slowly migrate toward the middle, creating one enormous bulge of sea at the center of the world, while the edges ran completely dry. Life at the edges wouldn't just be hard, it would be physically impossible. Now let's talk about the sun. In the flat Earth model, the sun works like a spotlight hovering above the disk, circling overhead in a slow loop. That sounds simple enough. But think about what that actually means. If the sun is just a light moving above a flat surface, everyone on that surface would be able to see it at the same time. There would be no real sunset. The sun would just get smaller as it moved farther away and then come back. But we don't experience that. Half the world is always in darkness while the other half is in light, every single day, without exception. A spotlight above a flat disk cannot do that. The geometry simply doesn't allow it. Then there are the stars. If you live in the northern part of the world, you see different constellations than someone living in the southern part. Not slightly different, completely different skies. On a flat disk, that shouldn't happen. Everyone would be looking up at the same ceiling, but they're not. People in Australia see stars that people in Canada will never see in their lifetime. That's not an opinion. That's something you can check tonight with a telescope and a phone call to someone on the other side of the world. And now, the part that genuinely unsettles me. Without a spinning molten core inside the Earth, there's no magnetic field. And without a magnetic field, the solar wind, the constant stream of charged particles coming off the sun, would slowly tear our atmosphere apart, molecule by molecule, until there was nothing left to breathe. The flat Earth needs a different answer for that. And most of the time, the answer it gives is the ice wall. A wall of ice at the edge of the world, supposedly keeping the oceans from spilling off into nothing. Guarded, in some versions of the theory, by governments and organizations with enough power to keep every pilot, every sailor, every scientist, and every astronaut permanently silent. But here's the question that actually keeps me up at night. What's on the other side of the wall? More ice? Another world entirely? Or is our Earth just one small section of something much larger? An infinite flat plane stretching outward in every direction, with other worlds scattered across it like islands in an ocean we were never allowed to explore? That question right there is the one science doesn't fully satisfy. Not because science is wrong, but because the honest answer is, we haven't looked. And something about that feels intentional. Whether or not you believe the Earth is flat, the act of asking the question does something important. It reminds you that most of what you believe about reality is secondhand. You didn't measure the curve of the Earth yourself. You didn't calculate the gravitational constant. You trusted people who trusted other people who trusted someone before them. That's not a criticism. That's just what being human is. But there's a version of curiosity that refuses to just accept the map, that wants to walk to the edge and look over, not because it expects to find an ice wall, but because the act of looking, the refusal to stop asking, is the only thing that has ever actually moved our understanding of the world forward. The Earth is almost certainly a sphere. The physics, the stars, the gravity, the magnetic field, they all point in the same direction. But the flat Earth thought experiment gives us something valuable anyway. It shows us how fragile our assumptions are when you pull on them, how quickly obvious things become complicated when you actually try to explain them from scratch. The real mystery was never the shape of the ground beneath us. It's the darkness surrounding all of it, in every direction, that we still don't understand. Stay curious. Watch the next video.